In this lesson, we're going to review how to add uncertainty bars to your data points, how to draw a line of best fit, but something new that we're going to learn is how to add lines of maximum and minimum slope. So if you look at the data in your handout on page 27, here we've plotted the data that you'll see there at the beginning. Go ahead and take time to answer the questions that you see there in number 1 and number 2. Okay, so to add our uncertainties, first of all, in temperature, double-click on this, on temperature, click error bar calculation, and probably a good uncertainty for your measurement in the lab as we did it would be plus or minus 1 degree. So we'll click done, and you can see the error bar showing up there. For the pressure, we'll do the same thing, and probably a good uncertainty for those gauges that you would be using would be plus or minus 3 kilopascals. Now that would be 0.03 times 10 to the 5th pascals as you read it. And there we have our uncertainty bars. Okay, now we want to add a line of best fit. So to do that, we'll go to Analyze and Model, and we will click Linear and OK. Then remember what we're going to do is double-click in the box, enable the line drag, click OK, and then we're going to draw our line of best fit so that it goes through as many points as possible, and also so that it misses as many points as possible on either side of the line. And you can see that all of our data points don't line up exactly, but there's a pretty good line of best fit hitting as many of those points as possible. Okay, so now I will double click there to disenable the line drag, and there's our line of best fit. Something new that we want you to do in all of your graphs from now on is to add maximum and minimum slope lines. And we do that exactly the same way as we did for our line of best fit. So first I'll go to Analyze, and I'll go to Model, and again I'm going to choose Linear. I'll double click in the box, enable the line drag, but also just to kind of help me keep track of things, I'm going to change the color of this line to red, tomato red. And what I'm going to do now is I'm going to draw a line of best fit that would be my maximum possible slope through my uncertainty bars. And so I'm going to draw that there like this. I want to make sure that it goes through all of my uncertainty bars, and so that it is the absolute maximum slope that we could possibly have. So something like that. Okay, now remember, treat each of these boxes, treat each of these crosses like a box. So I want to go from this corner of this box all the way through this corner up here of this box. But I want to draw it so that I'm going through all of the data points and all of the uncertainties to give me the maximum slope that I could possibly get. Then I'll disable that. I'm going to move this down here now. And now I'm going to do the same thing to get my minimum slope line. So I'll go Model, Linear, double click in the box, enable the line drag, and I'll change the color of this one to blue, and that way it just helps me to keep track of which line is which. And now I'm going to do the exact same thing giving me the line of minimum slope that again goes through all of my data points or my uncertainty bars as possible to give me that minimum slope that would be there. And that looks to be pretty good. And I'll disable that so that it doesn't go anywhere. So now I have my maximum slope line in red. I have my average slope line there in black, and I have my minimum slope line there in blue. So you can see that. So if I wanted to find the uncertainties in my slope, I would take the difference between my average slope and my maximum, and then take the difference between my average slope and my minimum, and whichever one gives me the bigger value, I would report that as my uncertainty. Now, another thing that we're going to see from this is as the temperature is decreasing, so is the pressure. So if you look to page 28, you can use your graph then to predict pressures at different temperatures. One way to do this is to click Analyze and Interpolate. And now as you move your cursor, you can see that at, say, a temperature of 20 degrees, I have what my average pressure would be, what my maximum pressure would be, and what my minimum pressure would be. And you can see that as we go along. So if I go to 45 degrees here, or nearly 45 degrees, you can see what your pressure would be. Also, if you went to 0 degrees, what your pressure would be. Also, if you went up to 100. Okay, so if I click here and drag this so I can now see 100, I can now interpolate as to what the pressures would be at those temperatures. I can also do the same thing for the pressure. I can drag this down until I can see 150, and so if I keep going until I get to a pressure of 150, then I can find what my temperature would be that would give me that. Of course, you could also use your equation here with the slope and the y-intercept to calculate different pressures at temperatures and vice versa. If you look at question E, it asks about zero pressure. So I'm going to scale my graph back to where we started. Let's go all the way to 0. Auto scale to 0. And now I'm going to move my graph until I can now see what the pressures would be and what the temperatures would be beyond what I actually have. So you can see that 0 pressure for my maximum slope line is going to give me a temperature of about negative 214. And my average slope line, I'm going to have a temperature of about, well, let's see, let's get it to exactly 0 pressure there. And that gives me a temperature of about negative 275. And then for my lowest slope pressure, we're looking at a temperature of about negative 405. So if I wanted to find absolute zero, the temperature where there would be no pressure, where there would be no movement at all of the gas molecules, according to my data, I'm getting an answer somewhere around negative 275 degrees. But what would my uncertainty be? My uncertainty would be the difference between my average value here and my maximum value in this direction and my value in this direction. So we're looking at 274, and here a temperature of around 406. So the difference between negative 406 and negative 274 would be what my uncertainty would be in my value of absolute zero.